This is the Friday Shoes production. This is lesson 4-5 in your books on page 210. I can use proportions to solve problems. Well, what is a proportion? A proportion is an equation stating that two ratios or rates are equivalent. You call them fractions. Here's a proportion right here written in numbers. Here's one written in algebra, just with letters. But you can see that 6/8 is equal to 3/4. So any fractions that are equal to each other, we'll call them ratios and rates, just so you can change those numbers on top and bottom to fractions or decimals, parts of a number as well. And do you notice something? I do. Look at those cross products. That's the big part of this. Consider the following here. If you have A over B and C over D, the cool thing is when you do the cross products, A times D, that's equal to B times C. The products A and D and B and C are called the cross products of this proportion. The cross products of any proportion are equal. You can use cross products to solve proportions in which one of the quantities is not known. So if you're missing one of those, you can figure it out. So, 8 times 3 is 24, and 6 times 4 is 24. That's the basis of this whole thing we're talking about with proportions. Cross products are equal. With that information, we can do problems like this. It says, after 2 hours, the air temperature had risen 7 degrees Fahrenheit. Write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees Fahrenheit. Well, write a proportion. Let T represent the time in hours. All right, so we have T in hours, and we want to know how long it's going to take to get the temperature to 13 degrees. Well, we already know that it takes 2 hours to get to 7 degrees. So notice the proportion we've set up. What we do then is we multiply our cross products. When you multiply the cross products, you get 7 times T and 2 times 13. And we know that 7 times T is 7T, and 2 times 13 is 26. Now let's solve that by dividing by 7, simple division equation there. So we divide by 7, and 26 divided by 7 is 3.7. And the 7's cancel out on this side. So we would say it will take about 3.7 hours to rise an additional 13 degrees Fahrenheit. How about you solve these two for the two missing pieces there? Come on back, see how I do. Well, again, we have two fractions that are equal, two ratios that are equal. And we know that the cross products are equal. So I'm going to say 10 times x has got to be equal to 4 times 9. But they are proportional. It says that right there in the directions. How do I solve this then? Well, we had 10 times x, which is 10x. We have 4 times 9, which is 36. Now we just solve by dividing by this 10. And x is equal to 3.6, or 3 3/5. How about the second one here? Again, the cross products are equal. That's how we're going to solve this. 2 times y is equal to 5 times 34. What is that? Well, we have 2y on the left side, and 5 times 34, let's see here, that's going to be 170. We're going to divide by 2. 2's cancel out, and y is equal to whatever 170 divided by 2 is. Well, I know 160 divided by 2 is 80, so let's add on 5 to each. That's going to be 85. 85 and 85 make 170. So y is 85. What these are saying, again, in this one, it's 2 to 34 is equal to 5 to 85. Those fractions are equal. All right, let's move on to our second example. Making some predictions. During a blood drive, the ratio of type O donors to non-type O donors was 37 to 43. About how many type O donors would you expect in a group of 300 donors? Well, when there's 37 to 43, what that's really saying is, these are the O and these are the non-O. There's actually how many people there? There's actually 80 people there. All right, so let's find out. If we had 300 donors, how many type O donors would we have? Right, and solve a proportion. Let T represent the number of type O donors. So we're going to use T for type O donors. And how many would you expect to see in a large population, or 300 people here, 300 donors? Well, write the ratio for the given information, and that's where that 80 comes into play. We got 37 type O donors, and then we have a total of 80 donors that we're looking at. 37 of them will be O, and then the other 43 will be non-O. So the number we're going to use is going to be 37/80ths. So let's take 37 over 80 and set that equal to how many people will there be, T, out of 300 that are O donors. And of course, you take your cross products, multiply them, and that's what we get here. 37 times 300 is 11,100, and then we have 80T. So we're going to divide by 80 on both sides, and when we do that, 80 disappears here, and T is equal to, they've switched it around here for us, it's about 138.75. And really, what does that mean? You would expect to find about 138, 139, if you rounded it, people with type O blood in a group of 300 donors. Great way to use proportions. How about you give your chance, or give your new learning here a chance on this one. Come on back, see how I do. Recycling 200 pounds of paper saves about 17 trees. Write and solve a proportion to determine how many trees you would expect to save by recycling 5,000 pounds of trees. So how many trees you would expect to save. We're going to call that T. T is saved trees. And we know that 200 pounds saves you 17 trees. Well, then how many trees would you save with 5,000 pounds of recycling? There's our T for our variable. Well, simply we're going to multiply the cross products and set them equal. So we have 2,000 times T is equal to 17 times 5,000. 17 times 5,000. That's the same as 17 times 5 and adding 3 zeros on that. So when I do 17 times 5, I'm getting myself, let's see, I'm going to do that in my head here. I'll show you on the side. It's going to come out to 85. So we have 85,000. So this is 85,000. That's equal to 2,000 times T. So now we'll divide both sides by the 2,000 to get T by itself, because that's what we're looking for. And when you do that, the T, or the 2,000s go away, and then we just have to take 85,000 divided by 2,000, which is the same as taking 85 divided by 2. When you take 85 divided by 2, it's going to be 42.5 trees saved. There you go. And our last example. You can also use the constant ratio to write an equation expressing the relationship between two proportional quantities. The constant ratio is also called the constant of proportionality. Write and use an equation. Let's try it. It says JC bought 8 gallons of gasoline for $22.32. Write an equation related to the cost to the number of gallons of gasoline. How much would JC pay for 11 gallons at the same rate? Really what you're doing is finding a unit rate. It says find the constant of proportionality between cost and gallons. That's basically the cost of the gas per gallon. So we take the $22.32 and we divide by 8, and that gives us $2.79. So the cost of $2.79 times the number of gallons that you're going to buy. So they're going to say, let C represent cost, let G represent the number of gallons, and then here is the little equation we use to find out what it's going to cost you to buy gas at $2.79 per gallon. Well, simply, they want to find out 11 gallons. All right. What we do is take our 11 and plug it in for our G in our little equation that we've created here. So when you take that 11 and you multiply it by the 279, you have the cost is $30.69. And that's what it says here. The cost of 11 gallons will be $30.69. Gas is getting cheaper than that now. All right, how about this one? You give it a shot. Come on back, see how I do. It says Olivia typed 2 pages in 15 minutes. Write an equation related the number of minutes to the number of pages. So you're going to see here, the first thing they do is take minutes to pages. Now, if she continues typing at this rate, how many minutes will it take her to type 10 pages? How about 25 pages? Well, to do 10 pages, let's figure this out. We have to find 15 minutes and divide it, because of this ratio here, which means 15 divided by 2. And we get 7.5 minutes per page. So we have it takes 7.5 minutes per page. So how many minutes will it take to do 10 pages? Well, we have to take and use this equation. M stands for our minutes, P stands for the pages, and 7.5 is our constant of proportionality. So let's take our 10 and plug it in for the pages that we want. Multiply 10 times 7.5, and that gets you 75. So it's going to take 75 minutes to do 10 pages at that rate. What about the 25 pages? Well, same thing. We're multiplying by P, which is 25 pages. So 25 times 7.5. Let me see if I can do this one here. We've got 5, carry the 2, that's 1, 2, 0, carry the 3, cross that out, put a 3 up there, that's going to be 1, 7. So we got 5, 7, 8, 1. Move over our 1 spot, 187. So we're going to have 187.5 pages. Or excuse me, minutes. It's going to take us 187.5 minutes to actually get through those 25 pages. All right, don't forget you can re-watch this video or read the examples in the book. These are the examples from the book. Or you can look at the personal tutor videos online through the online textbook. And as usual, this has been a Friday Shoes production.